Hello all, welcome to another session with me, Varun on Tech Tablet. And in this session, let us lay our foundation about understanding what is a linear regression and how we would be able to go further with regards to understanding this. So welcome, and without wasting any time, let's begin. So the agenda of the session is very clear and it's very straight. It would be to understand what is linear regression. We would also be looking at what are these two terms in specific, then the advantages and disadvantages, and we would be looking at some case studies and some interview questions. Well, I think this is very important for all those of you who are looking to enter into the field of data science. All right, so this keeping this agenda in mind, let us go further. And you all know me well. My name is Varun, and I have an experience wherein I'm heading towards my seventh year. I have started my career working as an SAP ABAPer, moved on into SAP UI5, then started my technical YouTube channel, which is Tech Tablet. I think it's 2.5 years is the age. And then I moved on into my rap videos. There's something I do for passion. You can go out and check out on YouTube with this name. That's the same account. You can also follow me on. And currently I work in the field of data science as a trainer and as a developer. So yeah, that's all about me. Now going further, guys, when we talk about linear regression is basically a split of two words, and this is where the concepts begin. Now when you talk about linearity, okay, and when you talk about regression, a lot of people, according to a lot of people, linearity is a line, linearity is 2 points, linearity is, a lot of blah blah. But then, guys, all these are wrong. Linearity is none of these. When you talk about linearity, linearity is a very simple word. Or linear is when you can say that both of them are in a relation. So here I can say it is forming a relation. Even this can be called linear because I'm able to understand the relation. All right. But guys, when you talk about something like this, it's not linear. Or when you talk about something like this, I wouldn't classify them as linear, or even a straight line for that case wouldn't classify or wouldn't call itself to be a linear if there's no relationship between each of them. And talking about the word regression, regression means to talk about the relationship. Now here I know that it is linear, but is it positive or is it negatively linear is what regression talks about. So if linear talks about the measure, regression talks about the relationship. All right. Now, here talk about linear regression. It attempts to model the relationship between two variables, and it's not necessarily only two. It could be more than two variables as well, by fitting a linear equation to the observed data. And we all know the equation is in the form of y equal to mx plus c. There's a lot of them who would, classify this in or write this in different ways. P is equal to b1x plus c, or yeah, there's a lot of ways to express this. But yeah, makes no difference as long as you know what linear regression or what this equation means. Anyways, one variable here is considered to be explanatory, that is dependent, and one variable is independent. Okay, so you have one independent variable and one dependent variable, or on each of the axis, one on the x and one on the y. And we would want to relate, as an example, we would want to relate the weight of individual to their height. So here I can say that this is my weight height chart, this is my height, and this is my weight, and I would put something like this. So here I can say that 1 2 3 4, and this is also 1 2 uh, 3 4. Now if you find data point here, you can say that with increase in height there is an increase in weight. The same can be inferred here as well. So there is a relationship that's getting formed between both of them. So guys, that is how we work on linear regression, or that is how linear regression comes into play. And going forward, there are two types of linear regression. The first one is simple, wherein in simple you have now considering this to be your x and this to be your y. Simple would have one on the x and one on the y. But when you talk about multiple linear relation, here you would be having more than one value on X, but only one dependent on Y. So this would be multiple, it would not be one anymore, but Y, which is your dependent, would still be only one value. So that is how we work on different types of linear. Now, this is the most basic variant. Now, this does not mean that there are no other variants or it's only these two. Well, there are still many others that we would probably want to know about. Here you see that you have polynomial regression, we have logistic regression, we have quantile regression, ridge regression, lasso, elastic net, and PCR as principal components regression. So if any of you is wondering that there's only two variants and these two variants are very easy to handle, well, there are other variants also, but no matter what, how many variants you have, linear regression would still be on the easier side of machine learning algorithm. Now, even this algorithm does not go or does not walk free from advantages and disadvantages, and now we will be talking about them. So the advantages, as you can see, are it's pretty easy to understand. It's not very difficult. Even the output is very easy to interpret. And then you have it's intuitive to use and understand. So these are like the ground advantages for almost all machine learning algorithms. But then here you have the next one, that is it is used to find the nature of relationship between two variables. That's also the use, and that's also the advantage of this machine learning algorithm. Now, it is pretty sensitive to outliers, which is a very, very big disadvantage. So if you have outliers in your data set, you would definitely want to treat them or clean them before you start applying your machine learning algorithm or your linear regression algorithm to the model. Now, are there any models which are not very sensitive to outliers? Yes, you have random forest, which is not very sensitive to outliers, but when you talk about linear regression, it is better that you are beware of the outliers before you start working on it. Now, going further, it is not suitable for non-linear data. Obviously, the name suggests that it is linear regression. So we don't expect this model or this algorithm to be suitable for all. All right, now these are the advantages and disadvantages that we have associated with linear regression. Now we'll move forward into case studies. I'm pretty sure you must be interested in knowing some case studies at least. So here I want to assess the risk in my financial services or my insurance domain. So here there's a small example. I might conduct a study or a linear regression to come up with the suggested premium table using predicted claims to my insured declared value ratio. So this is a pretty complex one. We'll keep it simple. Now I would want to see the number of patients and my increase in business, or I would want to see the number of visitors and my increase in business. So if my visitors are increasing, then my business would also increase. So this has to go like this. So guys, that is how we try to work on linear regression, or it could also be used to estimate the right temperature for it's going to increase the shelf life of cookies. Now, whenever you are, whenever you eat cookies, they have a life period or they have a lifetime. Now, if you overbake them, they might get spoiled in 3 days, or if you bake them under, they might get spoiled in 2 days only. Now there must be an optimum temperature wherein it would remain for more than 3 days probably. So this is how we work on linear regression, and all of these which we're talking about are based on calculation and are based on numbers. It is not something that we assume. Now, guys, the most important part of it, we'll look at some important interview question answers. The first one is, what are outliers and how do you detect them? Well, we all know what outliers are. If you have a team wherein the scores are 10, 20, 30, 25, 18, and 95, then yes, this player can be considered as an outlier, and we might want to remove his value from the team score, because that might change the total dimensionality of my team. All right. Now, the second one is, what are critical assumptions of linear regression? Well, it is imperative to have a linear relationship with the variables. The independent variables in data set should not exhibit collinearity, or they should not have multi-collinearity between them. And homoscedasticity is one of the most critical. Now, what is homoscedasticity is exactly the next question. As you can see, it states that there is no equal distribution of error terms. All right. If there is heteroscedasticity, then there is a problem. All right. Now, whenever you have had a homoscedasticity, you can use a log function to rectify this problem. Now, going further to the next three questions that we might want to watch. And those three questions are, can we use linear regression for TSA, that is time series analysis? Well, yes, you can use, but to be very honest, it wouldn't be very fruitful, because when you talk about time series, it mostly has these factors, that is peak or festive seasons or a repetitive kind of a data set. And when you talk about linear regression, right, it also does not talk about future, or there is no relevance or nothing to do with prediction of future. So if you are really looking forward to having linear regression for future purposes, then I don't think they would gel in very nicely. Now, how do you know? The next question is, the fifth one. How do you know that linear regression is suitable for any given data? Well, guys, honestly, no data is suitable for any given data. We make it suitable, and how do we do that? That is by applying some transformations. Now, these transformations could be, removal of outliers, or probably filling up of NA values, all right, or standardization, or normalization, plotting. There's a lot of things we do to ensure that your data is, brought back to the way you want before you're applying any machine learning algorithm. Then going to the next part, how do you interpret a QQ plot? That's a quartile plot in a linear regression model. Okay, now firstly, why do we use a QQ plot, guys? It is used to check the normality of errors. And in the above chart mentioned, majority of the data follows a normal distribution. Okay, now this shows that errors are normally distributed, but some observations may be due to highly significant or lower values which affect the normality of errors. So guys, in short, to keep it very crisp and easy, QQ plot is used whenever you would want to check the normal distribution of your error. Is your error normally distributed or not? And if it is not, then we would go back to transforming it, or we would go back to treating it. And that's exactly where the concept of homoscedasticity or heteroscedasticity would come into picture. So guys, I hope you have understood what we're talking about. I hope you understood what is linear regression, why do we use them, how do we use them, and advantages and disadvantages of the same. In the video to come, we will be talking about logistic regression. We have another part on linear regression, that is linear regression part 2, where we will be talking a bit in depth about the same model. Then we will be talking about decision trees, random forest. So guys, there's a lot that's yet to be talked and exchanged. So please do not go away anywhere. Stay tuned, stay subscribed. And also, if in case you find the video useful, guys, please feel free to hit the like button, as that would motivate me to do further. Also use the share button to share this with your friends, and do not forget to subscribe, because when you do that, it would definitely encourage and motivate me. And notwithstanding that, you would also be regularly updated if you hit the subscribe button followed by the bell icon. So guys, thanks a lot for being there. This is me, Varun Rao, signing off, wishing you all the best and a great day ahead. Thank you.